Children, in this video we are going to see Magnetism Part II, that is magnetization, demagnetization and uses of magnet. Magnetization, that is making a magnet. The process of imparting magnetism to a material using a permanent magnet or electricity is known as magnetization. So there are many methods to do this. Let's see few methods. Single touch method. AB is a small plate made of iron which is to be magnetized. AB is placed on a flat wooden bench. A permanent magnet is placed with its north pole touching end A. The magnet is drawn from end A to end B and is lifted. The process is repeated several times. This is how the single touch method works out. Next is the double touch method. In this method, two permanent bar magnets of equal strength are used. Opposite poles of the two magnets are placed touching AB at the center and drawn at same speed at same time towards the ends A and B. The process is repeated several times. In this case, the end which is in contact with the south pole becomes the north pole, while the other end becomes the south pole. Let's see the next method, that is the electrical method. When current is passed through a copper wire, the wire behaves as a magnet. When the switch is closed, current passes through the wire and iron nail is magnetized. When current is stopped, magnetic property disappears. A long insulated copper wire is wound over a hollow cylinder made of glass, cardboard, asbestos or plastic from one end to the other so that the turns are close to each other. The ends of the wire are connected to a battery and key. A rod made of iron is placed inside the cylinder and current is passed for some time. Now the iron rod gets magnetized and it behaves as a magnet. Let's see about the temporary and permanent magnets. When we magnetize some materials like the knitting needle, they retain magnetism only for a short period of time. So the materials which retain magnetism only for a short period of time is called as temporary magnets. Now let's see about the permanent magnets. The materials that retain magnetism permanently, they are called as permanent magnets. Examples of this are materials like alnico, that is an alloy of aluminium, nickel and cobalt, and soft iron retain magnetism permanently. They are called as permanent magnets. Let's see about the differences between temporary and permanent magnets. Temporary magnet. These magnets lose their magnetic properties as soon as the magnetizing force is removed, whereas the permanent magnets do not lose their magnetic properties. Next is, it cannot convert an ordinary place of iron into a magnet because of its weak power. This is in the case of temporary magnet. Now coming to the permanent magnet, it can convert an ordinary piece of iron into a temporary magnet. And the last point is temporary magnets is made up of soft iron, that is a pure iron, whereas a permanent magnet is made of steel, cobalt and nickel. So these are the differences between the temporary magnet and the permanent magnet. Let's see about the electromagnets. Some materials exhibit magnetism as long as the wire wound over them carries current. When the current is switched off, their magnetic property is lost. These are called electromagnets. Examples of electromagnets are calling bells, telephones, lifts, elevators, electric motors, televisions, and cranes make use of such electromagnets. Let us see about the demagnetization. The process of removing the magnetism of a magnet is called as demagnetization. Let us see how the magnets lose their magnetic property. First is, if we drop from a height, it loses the magnetic property. Next, hitting the magnet with the hammer. That is, if we hit a magnet with a hammer, it loses its magnetic property. Next is when we heat the magnet strongly, it loses its magnetic property. This is how the magnets lose their magnetic property. There is also another method, that is, sometimes the magnetism of a magnet weakens with time. This is known as a self demagnetization. Let's see how to take care of the magnets. The magnets are placed in pairs separated from each other with a piece of wood such that the opposite poles of the two magnets are closer. Small plates of soft iron called keepers are placed across the ends of magnets. This is how you have to keep the magnet safe. Let's see about the splitting of magnets. What happens when a bar magnet is cut carefully into two identical pieces? The two pieces still retain magnetic property, but strength will be lower. What about their poles? When a magnet is cut lengthwise, the two magnets have like poles on the same side. When cut across, the two ends on either side of the cut line attain opposite poles. Let's see about the uses of magnets. Let's see some of the uses. Magnetic toys, stickers, refrigerators, door stoppers, doorbells, computers, generators, loudspeakers, microphones, telephones, audio and videotapes make use of magnets. Magnetic cards like credit cards and identity cards are used every day. Strong magnets are used in lifts, elevators, cranes, etc. Magnetism is involved in fast moving electromagnetic trains like bullet trains. These bullet trains are also known as flying trains. These trains need a special type of magnetic track, and the bottom part of train has strong electromagnets. Using electricity, the polarity of these magnets is changed very fast, which makes the train to move fast. They can move at a speed about 400 km per hour. These trains do not make noise and do not pollute our environment. So, what are the advantages of this bullet train or the flying train? It can move at a speed above 200 km per hour, and these trains do not make noise and they do not pollute our environment. Where can we see these bullet trains? These trains are used in the countries like Japan, China, France, Germany, and America. Children, I hope you would have understood about the demagnetization, the care of magnets, the splitting of magnets, and the uses of magnets. Thank you.